Our next presenter is Christian Giese. He is a BNG protocol developer and professional service engineer at RT-Brick, specializing in PPPoE/L2TP, DHCP, radius, and related access technologies. He started his career at Deutsche Telekom AG in the Access BNG department, before moving to Juniper Networks. Please join me in welcoming Christian to the stage and enjoy the talk.
Yeah, thanks for this nice introduction. So it's now 18 years ago when I started to work on my first BNG project, at this time testing PPPoE on the Redback Smart Edge 800. And since then, I worked with many customers on various different PPPoE and IPoE deployments all over the world. And in almost all discussions, the comparison between PPPoE and IPoE has been framed to legacy versus modern. And I would like to change this framing, since they both rely on protocols from the 90s, stretched far beyond their original purpose. But what really matters is how these protocol stacks actually affect your daily operations, troubleshooting, and the customer experience. But before we go into the actual presentation, please take a moment and think about which of these protocol stacks you intuitively prefer, because a lot of you already have an opinion, have a lot of work experience with BNGs and protocols. And after the presentation, please think back and see if your opinion has been confirmed or maybe perhaps changed. But let's start with what is PPPoE and what is IPoE. Both are technologies or protocol stacks used between the CPE at home, so your Fritzbox, your Speedport, or whatever CPE you use, and the BNG of your service provider. And they are used to authenticate the subscribers, so the customers at home, to give them the dynamic IP addresses and do some basic, really basic configuration of the services like DNS servers, the MTU for PPPoE, maybe giving the URL of the ACS server, but it's just the basics you need to go into the internet. It's not a CPE management protocol. And I always talked about protocol stacks, not protocols. And this is because an example for PPPoE, of course there is the PPPoE protocol, but the PPPoE protocol is an extension of the actual PPP protocol to be usable over Ethernet. And then there's also the actual PPP protocol. Then we have authentication protocols like PUB and SHAP. There is the, for IPv4, we have the IPCP protocol. We have the IPv6 protocol for IPv6. But we also have ICMPv6 route advertisements, as well as DHCPv6 for delegated prefixes. And they are slightly different implemented for PPPoE than actually implemented for normal Ethernet networks. So they belong to the PPPoE stack here. There is a tunneling protocol in PPPoE called L2TPv2, which allows to extend the PPPoE session over a layer 3 network. And there are many legacy options like the PPP compression protocol are excluded here. But you see that's a protocol stack instead of just a single protocol. And then on the other hand, I have IPoE. And in IPoE, we talk about two fully independent protocol stacks instead of one large protocol stack. We do have for IPv4, DHCPv4, plus obviously ARP, proxy ARP. And in IPv6, we have DHCPv6 and ICMPv6 for route advertisements, for neighbor discovery. So you can see here on this picture that we have on the one side, we have PPPoE as a very large, feature-rich stack, transporting all the protocols, all the sub-protocols. And on the other hand, we have two very lightweight, fully independent protocol stacks for IPoE. So let's explain this a bit better on a session setup. In both cases, in PPPoE and here in this example for DHCP, the CPE starts with a broadcast message. So in PPPoE, it's a PPI message, in DHCP, it's a discovery message to search for BNGs. And in both cases, it's possible that one or multiple BNGs may respond with an offer. So it was very popular to use this for redundancy, just put more BNGs into a broadcast domain. And then the CPEs have to select out of the offers one of them and do request the actual service. So in the first view, you could think about these are very similar protocols. The handshake looks very, very similar. But for DHCP, the session setup has been finished. Of course, a bit of address resolution and ARP is needed, but we are actually almost done. In PPPoE, we just started. So now in PPPoE, we go to the link phase, then there's the authentication phases. We do have then the actual IPv4 and IPv6 network phases, and then finally our keep alive switch continuously running. So you could think about definitely PPPoE is the more complex stack, but before coming to this conclusion, don't forget we have to do it twice for IPoE. So instead of having one large stack, we have to do everything twice. And for DHCP-v6, we also again send in this case, a multicast message. There's no broadcast in IPv6, looking for BNGs, and then also one or two BNGs or more can respond. And then there's the first problem we have with two stacks. In this very simple example, having two BNGs, it might be possible that IPv4 selects BNG1 and IPv6 selects BNG2. It's a problem. Of course, there are solutions vendors figured out to solve this, to control this, but this also adds additional complexity to your protocol stack. So therefore, finally you can say, okay, maybe the difference is not that big in complexity here. So, and of course, we have to deploy protocols. And in PPPoE, the BNG is always the PPPoE server, and the CPE at home is the PPPoE client. And between the PPPoE client and the server, you very often, not always, have an access node, an Amazon, an OLT, and they can run an intermediate agent. This is defined in the TR101. And the intermediate agent is used to, let's say, take the packets sent from the client to the server. So in this case, the DHCP discovery packages, the first 4 packets, and add additional informations into. So which means the Amazon or the OLT takes the packets and adds the description of the physical port. So for DSL, it gives information which DSL port is used. It can give information which bandwidth was dynamically negotiated, which DSL protocol is used, which framing, and of course the identifier of the line, which then can be forwarded to the BNG, and then the BNG can authenticate the customer either based on these informations or for PPP also based on the username or the password, and authentication, not always, but very likely happens then in the radius server. And if you go to IPoE, it looks very similar. So the BNG might be the DHCP server, the CPE might be the DHCP client, and also the OLT or the Amazon may behave as an intermediate agent. But again here, the OLTs or the Amazons have to do it twice. So there are 2 different protocol stacks. We have 2 different intermediate agents. One for DHCP-v4, which is called layer 2 DHCP relay agent, as defined in the TR101, and the DHCP-v6 lightweight DHCP-v6 relay agent, as defined in an RFC. And they should hopefully add the same informations in both protocols, because we don't know which one comes first. And we authenticate with the first protocol to subscriber. And again, you may have radio servers. It's not mandatory, but likely you do have. But in IPoE, there's an alternative. You can also have a centralized DHCP server. So then instead of acting as a DHCP server in the BNG, we can just forward the messages to the DHCP server. But you may think, why is there still a radio server in this picture? And this is because the DHCP server cannot replace the radio server. So very likely you still need also a radio server, because you cannot do accounting in DHCP. I cannot inform the DHCP server about how many data volume was used. I cannot change the cross profiles. So typically what you do here is that the first DHCP packet is then buffered in the BNG, and then a request is sent to the radio server. Then the radio server can authenticate, can inform about, okay, this is the bandwidth the customer has booked. These are the cross profiles. and only then the packet is forwarded to the DHCP server. So you see, if you decide for this option, it doesn't mean you don't need a radius server. You just have 2 servers. But there are advantages of doing this. And yeah, it's a popular thing. People do this. Sometimes people run a DHCP server. Sometimes people prefer to run a BNG, which is also a bit like, depends on the feature stack of a BNG. Because, of course, if you use the DHCP server, you may have more control over DHCP options. But, of course, a lot of BNGs also have the possibility to control almost all DHCP options. So it's a bit depending on the actual BNG vendor you have, which solution you likely select. So, but let's go into the detailed comparison. So this is why we are here, see which protocol, how the protocols compare to each other. And I would like to start with a very important thing here, and this is interoperability between clients and servers. And in my opinion, PPPoE has the much better client compatibility. And let me explain why I think this is the case. And a very important point here is framed routes. So assigning an IP address, especially if I use public IP addresses, is very likely we all prefer to just give a host address. So I just assign multiple /24 networks, I chain them, and then just assign one address by address by address. But I would not reserve a gateway address, a network address, and then just ensure that I have a gateway and network in the same IP address. So I just give addresses and use my loopback address as the default gateway. This is the most comfortable way and most address-efficient way to handle IP addressing. But actually, it's not permitted in IPoE because the DHCP or the IP standard enforces that you have your default gateway in your network. But your network is a /32. It's not possible. But a lot of CPEs support it. But there are also some CPEs, they say, no, it's not permitted. I don't support it. But CPEs built for the broadband market often support it. But still, it's a hack. It's nothing which is officially standardized. So even if it's common, it's not a standard. Then IPoE relies heavily on proxy up. Proxy up means that the client sends an ARP request for an IP address, and the BNG responds even if this IP address doesn't belong to him. And this is important, in special with /32s. We have seen a lot of CPEs doing very strange things if we assign a /32, meaning that they sometimes start resolving their DNS servers via the BNG. Then we get a lot of IP address requests to resolve for WAN addresses. Okay, then we have to resolve them. We have to respond with our own MAC address. But also if I use a, let's say, more classic approach, having a network, the IP in the gateway, if the clients would like to communicate within the subnet, then of course we need proxy up because we prevent communication between clients not going over the BNG for legal reasons. And another important point is DHCP-v6. DHCP-v6, compared to DHCP-v4, only assigns the WAN address and the LAN addresses, but not a default gateway. But I have seen a lot of deployments, or a few deployments, actually not a lot, they don't send route advertisements. And then the CPE market solved this problem by just saying, okay, if the BNG doesn't send a route advertisement, let's create a default gateway out of the DHCP-v6 source address. Okay, it works, but again, it's a hack. And it's something we also have here in Germany. I have seen this, and then CPEs here in German market, they implemented this hack. And they say, but yeah, it doesn't make it good. It's still a hack, it's a workaround, and we heavily rely our internet on undocumented workarounds. So also not a good idea. And this brings me to the conclusion to say PPPoE has the better compatibility because it's fully standardized. There's not much CPEs can do differently compared to as we have it in IPoE. Then one of the pain points for PPPoE, MTU. So the internet uses MTU 1500. All data centers or servers, my homeland is always 1500, but PPPoE is limited to 1492. So there is a high risk of fragmentation. But again, CPEs are smart. They invented MSS clamping. MSS clamping means that the CPE just takes the TCP packages, and in the TCP handshake, they change the maximum segment size to ensure that there is no fragmentation happening. And this works pretty well for TCP, but not for UDP. And a lot of UDP is quick, but luckily, the people behind QUIC, they decided that QUIC has a maximum packet size of 1280 bytes, so no issue for PPPoE. So then the only remaining pain point here is zip a bit. Zip has very large UDP packets. And this is the most fragmented packet you see in PPPoE, are zip, because they are always then fragmented out of the data center because it's bigger than 1500 bytes. And then we have to fragment the fragmented packets again before we send them to the client, which works. But yeah, it's not nice. But we also have a solution here. It's the RFC 4638, which is supported by almost all BNGs in the market and allows to negotiate an MTU 1500 on PPPoE, but it's not heavily deployed. So the BNGs, they typically support it, but the number of CPEs supporting it are limited. Luckily, the most common CPE in Germany supports it, but it's not enabled by default. And the nice thing on this RFC is the protocol developers decided that the CPE first has to signal in the PET-I message, I support this RFC. Then the BNG has to send, I also support it. And then they know we can negotiate a larger MTU. So it's very risk-free as an operator to enable it, because CPEs don't supporting it, they will not have any compatibility issues here. And if the CPE supports it, they can negotiate higher bandwidths. So I highly recommend for all of you operating PPPoE, please enable it. And then also enable it on the CPE, and then we have less fragmentation here. Multicast. Multicast was one of the drivers for the success of IPoE. And you know, in PPPoE, it's a point-to-point protocol, which means I have a tunnel between the CPE and the BNG. And this means the last replication point I can have is the BNG, which means if there's the football world mastership, I have to send the same game again and again and again over my aggregation and access network, which isn't that efficient. And in comparison, in IPoE, I can have further aggregation, multicast replication points in my aggregation. And very popular on OLTs, they have a smart feature that they can even send the multicast channels only once per PON tree. So they have dedicated multicast gem ports, so you can also ensure that even within the PON tree, every multicast channel is only sent once. And this was very, very popular and was one of the main drivers here. But again, you all know multicast becomes history. So the trend goes to unicast TV. And therefore, it's up to you if this is a very important thing for your network or not. If you only have unicast TV, maybe you can ignore this point. If you rely heavily on multicast, this is an important point for you. Keep alive. PPPoE has a built-in feature for keep alive, meaning the client can send keep alive messages, the server can send keep alive messages, typically every 30 seconds. And then you can very fast identify if there's an outage of the server, of the link. The server can identify the CPE has been disconnected or there's an outage. So it's very stable for your network to have keep alive. In IPoE, unfortunately, we do not have. And some vendors, they implemented some workarounds. They say, okay, let's use ARP as a keep alive or neighbor discovery as a keep alive. But it's something you cannot heavily rely on. And it only works in one direction. The BNG may identify with this if the CPE is still there. But the CPE cannot identify the BNG is still there, because then the CPE needs to implement this. And as a BNG vendor, we would not be so happy if the CPE starts sending massive ARP requests. So we would not push this into the market. And keep alive is important for this topic here, which is redundancy. And redundancy, we have to split in stateless and stateful redundancy. And you may remember the first flow diagram I have shown with the two BNGs in the network segment. And it was very popular to do stateless redundancy, just meaning I have my broadcast domain, I put 1, 2, 3, or 4 BNGs into this, and then multiple BNGs can respond to, and I can control this a bit, which one and how to balance the load. And it's just simple and stateless. So if the BNG has an outage, then the keep alives ensure that the client recognizes this, reconnects, the next BNG takes over. And this is super, super stable and efficient. It even works with different vendors. You can say vendor A, vendor B. I can have different software versions. It doesn't matter. They don't need to talk to each other. This is super nice and very, very popular in PPPoE. But as you see, they rely on reconnecting the CPE. So which means without keep alives, it may take a lot of time for the CPE to identify the BNG has been reconnected or has been an outage to reconnect on. And this is why you see that Stateless redundancy is very, very popular for PPPoE, but a bit less popular for IPoE, because here I don't have to keep alive. And therefore, IPoE deployments, if you see redundancy, very likely they use stateful redundancy, which means you have two BNGs, and then you have synchronization protocol between, which is normally proprietary because there is no standard for this. And then you need two BNGs from the same vendor with compatible software versions, and then you can replicate your actual state between the two BNGs, and if there's an outage, the other BNG can take over. Which has the advantage that the downtime is shorter, maybe a few seconds, compared to, let's say, 90 seconds, maybe in PPPoE, depending on your keep alive interval. But it has a higher risk of failing, because it's much more complex. You rely on the same software version, so even if it works much better. There is a complexity that it doesn't work, and if it does not work, troubleshooting it is not that simple. So yeah, you see there are these two different options, and yeah. Authentication. I explained before that there is the possibility that the OLT or the access nodes, they can add additional informations into the PPPoE or DHCP packets, identifying the customer line. And this is heavily used to authenticate customers, in special for IPoE, and it's also the only way to authenticate IPoE customers. Of course, you may use the MAC address of the CPE to authenticate a customer, but then you have to trust the MAC address. Whereas the intermediate agent you can trust, because they also override information. If the client manipulates the CPE, adds this information, the access nodes are written to wipe out the information sent from the client, override this with there, and then you can use this as a trust anchor to identify this is the customer A, this is the line of this customer, I can authenticate this. And this is line authentication, which works for PPPoE and IPoE. But if you do not have the possibility to add these informations, then authentication is possibly much more difficult for you. And then you possibly prefer PPPoE, because here you can still use username and password, which you cannot do with IPoE. And then there is something I really miss for IPoE. This is the server-side disconnect. Server-side disconnect means I, as an operator, being able to force the CPE to reconnect. And this might be very important, in special for maintenance cases. I would like to reboot my BNG, then I just send a message for the CPE, so I don't need to wait that they identify on keep alive that the BNG has been rebooted. Or another important use case is sometimes you change your configuration in a way that the BNG cannot apply the changes without reconnecting. So then you change your configuration, you wait for the maintenance window, and then you kick all your subscribers, and then after reconnecting, they have the new configuration applied. But for IPoE, you have to wait for them to reconnect. It's much more difficult. I know a few operators, they just use as a workaround. If they need the CPEs to reconnect for IPoE, they just switch off the OLTs for a few seconds, then there is a light off, and then the CPEs reconnect as well. But this doesn't work if you use an external modem behind an external ONU. But if you have an internal, it works. But it's some kind of a hack. I would love to have server-side disconnect in DHCP v6. Maybe someone in the working groups or in the IETF adds this to DHCP. This would be very, very nice here. And then performance. Performance is an important point here. And if you do have a physical BNG, an ASIC-based BNG, very traditional ones from the big vendors, then it does not matter if you do PPPoE or IPoE. They all have ASICs implementing these protocols at line rate. There's no issue here. But if you do have a virtual BNG, or maybe you have some kind of cheap BNG appliance, so there are some appliances on the market, they are working mostly virtual in software, but have some basic hardware offloading, then you often see an enormous performance impact using PPPoE, because, and this is the key here, the hardware offloading of these sometimes very cheap chips used for the offloading, they are often not able to pass a PPPoE packet, so they can do PPPoE offloading. And this is what you see then if you do some virtual BNGs, or if you use appliances with a virtual BNG forwarder or some CPE. Sometimes you use firewalls as a PPPoE client, and then you see why is the performance so bad, because they often use some kind of hardware offloading. And then if the hardware offloading cannot be used, you see enormous performance difference to IPoE and PPPoE. And this is why I say it depends, but in average, IPoE has a better performance. But most of the time, it does not matter. If you have a modern CPE at home, they have so much performance to even 1 gigabit connections on PPPoE. A hardware-based BNG even has no issue here, but there might be scenarios, especially for very, very small deployments, where this might be an important thing to you, that you have to consider that PPPoE may have an important performance impact on your setup. Then VLAN mode. In broadband, we have 2 VLAN modes, one-on-one and end-to-one, which means I have a dedicated VLAN for all of my subscribers. So one household, one subscriber is one VLAN. And end-to-one means in one VLAN, I can have multiple subscribers. And this is important in this context because if I use end-to-one VLAN mode, if I use PPPoE as a hardware vendor, it's very easy to still identify all traffic which belongs to one customer by just matching on the PPPoE session ID. It's a very small, tiny ID. I can use instead of the VLAN to say all traffic of this VLAN ID, I match into one logical interface. And this is my subscriber interface, and then I can attach my cross on it. And if I do IPoE, as I mentioned, I have 2 protocol stacks fully independent. I need to identify which traffic belongs together to do my cross operations on it, my accounting on it. And then we have to use the MAC address, which is slightly bit longer. And in some network or chipset architectures, this may have causes some limitations of the features that because of additional lookup step, you sometimes have some features that don't work with IPoE end-to-one, where they work with one-to-one or they work with end-to-one and PPPoE, because you need one more lookup to identify all traffic to one subscriber by the MAC address. Then accounting is not that important anymore. So both technologies, I can use volume accounting, but if you need, very unlikely, time accounting, then you prefer PPPoE, because here you have a proper first and last sign of life, keep alive, but likely or luckily, nobody is doing time accounting anymore. So therefore, this is not that important, but back in the time that we had time accounting, this was also something you would not do on an IPoE network. And then tunneling. So as I mentioned before, PPPoE supports L2TP. And this is some kind of a layer 3 bitstream access. And it's very, very popular because I don't need some negotiations with the wholesale partners. I just need their IP address. Okay. And then I can just tunnel my connection to them. So let's come to my final closing. After we have seen all the points left and right, or let me quickly go back, and you see a lot of green on the left side, a bit more green by PPPoE, and a bit more red on IPoE, but this doesn't mean PPPoE is the better protocol. Please don't come to this wrong conclusion here, because the question is not which protocol is better. The actual question here is which protocol is better for you. And for you means if you need multicast, it's clear which one you need. If you need L2TP, it's an easy decision. If you have a virtual BNG, of course you prefer IPoE. So it's not like PPPoE is better, IPoE better. It depends on your setup. So finally, I would say PPPoE is not a legacy protocol, but IPoE is not modern. And both are hacks for broadband. And which one you prefer is up to you.
Thank you, Christian, for this insight. We have time for some questions. Please remember to state your name and affiliation before asking your question. We will also relay some questions from VenueLess if time permits.
Yes, thank you very much for that amazing presentation. My name is Daniel from the DEDISCON, and I have a question to your to the overview. What do you think about the QoS marking in the upstream for PPPoE and IPoE? I think it's a little bit challenging for PPPoE, right? The QoS marking.
The cross marking, I think here is no big difference for both protocols. So this works in both cases, very similar. So I don't see this as a driver to decide between one or the other. So cross markings, rewriting, yeah. Of course, you have IPv4 and IPv6 different markings, but yeah, it's not one of the drivers.
My name is Thomas. Sorry.
Hi, Sylvan from Open Factory. One question about IPoE that I'm currently working on is the support of framed routes, especially in a wholesale environment, because that's normally realized as DHCP relay to radios with VRFs over BGP.
Yeah, frame route is always a difficult topic because it's easy to inform the BNG about the framed routes which are available behind the CPE, but it's very difficult to tell the CPE which framed routes they have to get, because there's no standard protocol to do this inline. You always have to do this externally to inform them. So there's no DHCP options or PPPoE options to say, okay, you have this, and this network behind you, unfortunately. But there are options to tell the BNG which networks are behind the CPE, but we cannot tell this to CPE. So you always have to do this inline, or you have to pre-configure the CPEs, or you have to use an additional protocol for this. But we cannot signal this in the DHCP session or in the PPPoE session directly.
My name is Thomas Schäfer, University Munich. As I've seen your investigative the dual stack scenario.
Yes.
Did you have also a look of DS Lite, which may have more advantage and disadvantage in both cases?
Yeah, the advantage is if you do DS Lite, you have only one protocol stack for IPoE, which halves your problems. So you only have DHCP v6 then, and then it's much easier to operate IPoE. In general, you could say if you do single stack DHCP v6 only and do IPv4 as an overlay, then of course a lot of issues you may have with IPoE you don't have anymore, because you have only one stack to operate instead of two stacks to synchronize. But most likely people do dual stack IPv4, IPv6. But yeah, if you do single stack, things are becoming easier.
Well, that's a wrap for this presentation, and please rate to talk. And now it's time for coffee. Enjoy. Thank you.